So given this interval tree, how do we solve the problem that we described in the previous video? How do we find the set of intervals that intersect a vertical query line? Let's look at a case here. So imagine that I have this interval tree. Remember that the set of line segments that I store here are a set of line segments that intersect this dividing line that I draw at this point. I do something a bit interesting here, and that is I store every line segment twice inside this node. That only doubles the amount of space that I'm using. And I store them using two different orders. Once I store them as an increasing order of the left endpoint, and the other one as a decreasing order of the right endpoint. Okay, so for example, if I look at the left endpoint, I stored, this is going to be, this is sorted, this is the 1, 2, 3, 4, and so on. Okay. The reason we're doing this is going to be obvious in a moment. Okay. So now let's say I want to answer a query. I have this tree with this structure, and now given a vertical line, I want to find all the line segments that intersect this vertical line. Okay. So let's say this is my vertical line. So to answer this query L, I do two things. First, I need to find the set of line segments that I stored inside V that intersect L, and then I have one recursion. So since L is a vertical line segment, it can only intersect the intervals stored at the left subtree or the right subtree. In other words, if L is to the left of this dividing line, I recurse on the left subtree. If L is over here, then I need to recurse on the right subtree. So there is always one recursion step. And that recursion step takes care of finding anything that is inside these children that intersect this L. So that means the only thing left to do at this node V is to find a set of line segments that intersect L that are stored inside V. And to do that, we can just easily observe that I just need to, like in this case, when L is to the left, I just need to start scanning from the first to the second, etc. Right? So if I look at the first line segment that is stored over here, that has the line segment that has the endpoint farthest to the left of this dividing line. If this does not intersect L, so for example, if L is like this, then I know there is no input. Otherwise, I just report 1, then I go to 2. So here 2 also intersects, I report 2, then I go to 3. 3 does not intersect L, therefore I know that the remaining line segment 4, 5, etc. will also not intersect because their endpoint is to the right of this line L. Okay, so therefore if I have K intersection, I only need to spend K plus 1 time to report all these line segments. Okay, so therefore the time it takes to report K segments from the segment stored at V is K plus 1. And also remember that we have exactly one recursion. So therefore, ignoring the time that it takes to report the output, the query time can be bounded by this recursion. Q of n equals Q of n half plus O of 1. Okay, and this obviously solves to log n time. So this data structure can actually solve these queries in log n time.